All right, let's take a look at some more problems here. Let's do the example 1 on the back of the first page. This is a composition problem. Given that f of x is x squared plus 3x plus 5, and that g of x is x plus 4, find f of g of negative 5. So I always kind of rewrite this where we put the negative 5 inside the g function. So this is the same notation. I always use this because now I see that what I really need to find is g of negative 5, and then plug that value into these x's for the f of x. So what is g of negative 5? We take our g of x function. Anywhere we see an x, we replace it with negative 5. So we get negative 1. So g of negative 5 is equal to negative 1. So what I'm really finding now is f of negative 1. So, to plug it in by hand, we just plug negative 1 into the f of x function. It's important to put your negatives in parentheses as you square them. So negative 1 squared is 1, plus 3 times negative 1, that's negative 3. Bring down the plus 5. So 1 minus 3 plus 5 is positive 3. So f of g of negative 5 is equal to 3. So let's look at some more. There was a request for this one. Also, this is the one I kind of I put some of the pieces together, the behavior and then the multiplicities. So let's talk about this one a bit more. When it's factored, our polynomial, we don't even need to graph it. Some of you can just see how these go just by looking at it. So the end behavior, that's your 4 different cases. Here, what would our leading term be? We would have an x times, if we FOILed this out, we would get an x squared as our leading term, times this x right here. This will give us a x to the 4th polynomial. And what is the end behavior like for a polynomial that is even and positive? Just like an x squared, the left hand will go up and the right hand will go up. So left hand up, right hand up. So that's part A. To find part B, what is the y-intercept? To do this by hand, the y-intercept is where x equals 0. So if we zero out the x's, what we have left is a negative 1, and this becomes 2 squared times 0 minus 3 is negative 3. So negative 1 times 4 times negative 3. That's A negative times a negative will give us a positive. 4 times 3 is 12. So it's at 0, 12 for the y-intercept. Of course, the other way to do this is to put this in the calculator, and for b, it's, go to the table where x is equal to 0. So zeros and their multiplicities. This is what I wanted to kind of clarify. The multiplicities is how many times do we get this solution. And again, zeros are the same as solutions. So this is in factored form. If x minus 1, and again, for a 0, that's where we set y equal to 0. And we would set each factor equal to 0. So if x minus 1 equals 0, then our solution is at x equals 1. So the zeros and their multiplicities, we get x equals 1 with a multiplicity of 1. And then we get x will equal negative 2 as we set that equal to 0. And that has a multiplicity of 2 because of the exponent of 2 there. And again, when it has an even multiplicity, that's where we bounce off of the x-axis, which is the behavior at the 0. Our final 0 is at x equals 3. And that has a multiplicity of 1. And then we talk about the behavior at each 0. Again, if it's an odd multiplicity, it will cross. So we cross at x equals 1. But we bounce or touch. But I need to see something like bounce because it has a multiplicity of 2. And if it's an odd multiplicity, then it crosses. And then you'll be able to sketch the graph. So finally, let's look at a problem like number 25 here. We have to decide what is x and what is y. 1 Snickers bar and 2 Milky Way bars have 737 calories. So we'll say that x is the, because it says find the number of calories in each bar. So x is the number of calories in a Snickers, whereas y will be the number of calories in a Milky Way. So our first equation is that 1 Snickers plus 2 Milky Way equals 737. And then we have that, this next one here, 2 Snickers bars plus 1 Milky Way equals 778. And so we are going to use some row operations so that we can solve this down and solve for x and y. So this is we would use the elimination method here. We need to create our opposite variables. I could either multiply the bottom equation by -2, which would give us 2y on top, -2y on bottom. Or I can multiply the top by -2. And that will give us, again, this is our target here, -2x and +2x. So I have -2x minus 4y equals, let's put this in the calculator, 737 times 2 times negative 2, negative 1474. And I will add that to row 2. And that gives us, the x's will cancel out. Negative 3y equals a negative 696. And then we can divide out the negative 3. And we get that y is equal to negative 232. So they want to see some Gaussian elimination. So in the Gaussian row operations we did here is we multiplied row 1 by negative 2, and we added that to row 2, and that became our new row 2. So that is the Gaussian elimination piece that using the row operations. And so once you find one of the number of calories in a bar, once we solve for y, I can go up here and solve for x. We'll use this equation right here, that x plus, no, that doesn't work. Getting kind of cramped here. So we know that y is equal to negative 232. I'm going to plug it into the original equation, which was x plus 2y equals 737. So we plug in our y into this equation. Again, we could pick either of the equations, but we want to solve for x, so we might as well use that first one. So we get x minus 464 equals 737. And we add that 464 to both sides to get 1201. So there we have it. I think I did everything right. Yeah. So, once you find one of the variables, you can just plug it into either of the equations to find the other variable. But it's really just a addition/elimination problem. So, if you have any last-minute questions, let me know. And good luck on the final.